This is the 50th video on Newton's laws of motion. This is in continuation of the 57th video. So in this video I'll take up two numerical problems which was asked in previous year's JEE Advance paper, in physics paper. Okay, I will take questions on one question on physics which was asked in JEE Advance 2024, and another question I will take which was asked in JEE Advance 2023. So I'll discuss two problems in this video. Okay, so first I'll write down the question which was asked in JEE Advance 2023. Okay, now the question is this. This was asked in JEE Advance 2023. I'll write down the question. A particle of mass m is moving in xy plane, okay, such that velocity v at point P x comma y is given as v is equal to alpha into yx hat plus 2x into y hat. 2x into y hat. Here x hat denotes the unit vector along x-axis and y hat denotes unit vector along y-axis. Question is, find the net force F acting on the point at an arbitrary point P x comma y. Okay, so this we have to find. So this question was asked in JEE Advance 2023. It's a fairly straightforward question. First, all you have to see, we know from Newton's second law that net force F is equals to mass times acceleration. It is well known form of Newton's second law applied to a particle. A denotes the acceleration of particle with respect to some inertial frame. In this case, it's ground frame. Nothing has been said, so ground frame is implied. We take ground to be inertial for all practical purposes. So this is written as m dv by dt. Let's write as I. I denotes some inertial frame. So this will be written as m d by dt of, instead of v I write this one, alpha y x hat plus 2 alpha x y hat. This is a differentiate in frame I, inertial frame. So this becomes m alpha is constant, x hat is also constant. So this becomes m alpha dy by dt x hat plus 2m alpha dx by dt into y hat. Now we know that dy by dt is nothing but the y component of velocity of the particle, but velocity is given as alpha y x hat plus 2 alpha x y hat. So y component of velocity is nothing but the coefficient of y hat, which is 2x alpha. So it is just equal to 2 alpha x. And what about dx by dt? Dx by dt is the x component of velocity. Dx by dt is nothing but the x component of velocity, and x component of velocity is the coefficient of x hat, alpha y. That is just equal to alpha y. So Vy is 2 alpha x, Vx is equal to alpha y. We substitute this in these equations, then we get the expression for net force on the particle. Fine, alright. So this is another bit now. This was a fairly straightforward question. If you just carry out, you have practiced a few questions in kinematics of point in a plane, this can be solved very easily, there is no doubt. So substitute Vy and Vx in this equation. So F becomes how much? M alpha, and dy by dt becomes 2 alpha x. So 2 alpha x into x hat. X hat, as I just said previously, it is a unit vector along x axis, plus 2m alpha into dx by dt. There is nothing but alpha y into y hat. So this is the answer. 2m alpha square becomes common. 2m alpha square becomes common. it becomes xx hat plus yy hat. This is therefore the required answer. So this is the required answer, okay. So this is a fairly straightforward question, okay. So this question was asked in JEE Advance 2023, fine. Now I'll take up another question which was asked in JEE Advance 2024, okay. First I'll grab this first. Now I'll take another question. This is also asked in JEE Advance 2024. Okay. I'll write down the question. See, the question was given in terms of various options. Okay. So I simply wrote down the question and gave the answer. I did not show the options in the question. Okay. I just wrote down the question and I answered it. I did not show the options which are asked in objective test. Okay. Fine. So another question, I'd say this. A block of mass 5 kg moves along the x direction subject to the force F equal to minus 20x plus 10 Newton. N for Newton, okay. With the value of x in meter and value of x is in meter. Alright. Value of x is in meter. At time t equal to 0, the point is at time t0, the block is at rest and at x equal to 1 meter. Okay, fine. Find the position and momentum of the object at t equal to pi by 4 seconds. So this question was asked in JEE Advance 2024. So again, see, it's a usual second order differential equation problem. But in Newton's laws videos which I made, so many videos which I made, I have solved several such questions I have solved which involve solving second order linear differential equation with constant coefficients. So this importance I have already stressed in the previous videos. Still I have taken this question, okay. So this force is the net force on the object block. So how do you start from this? Again, starting simple, we just apply the Newton's second law to the block along x-axis at some arbitrary time t. So solution. Mass times acceleration equal to net force. Mass of object is given to 5 kg, m is 5, into A. A becomes dv by dt. F is equal to minus 20x plus 10. 5 is common term, it cancels out. So this becomes d by dt. V is nothing but dx by dt. For our object moving along x-axis. From kinematics of motion of point along straight line, V is nothing but dx by dt. This 5 cancels out. Minus 4x plus 2. Now this term is d2x by dt2 is equal to minus 4x plus 2. Now this is a linear second order differential equation with the time as the independent variable and x as the dependent variable with constant coefficients. I bring 4x to left side. So the equation becomes d2x by dt2 plus 4x is equal to 2. Now see, this differential equation is of the form d2x by dt2 plus omega square x equal to alpha, where alpha is 2 constant and omega square is 4, that is also constant. So now we know this equation. I have previously taken so many questions on this differential equation. If you go and search the videos, you'll get all those problems. Such type of problems I have discussed in this video on the Newton's laws. This is the 50th video, na? So there are so many videos before also. You go and search them in the playlist, you'll get it. Okay. I got this one. So, solution of this differential equation. First, I write this equation again. d2x by dt2 plus omega square x barabar alpha, where alpha is constant, omega square is also constant. Solution of this differential equation is given as a1 cos omega t plus a2 sin omega t plus alpha by omega square. Now, this equation is of this form. So omega square is 4 by comparison. That meaning omega is just equal to 2. Alpha is also equal to 2, comparing. So you substitute omega and t in this, omega and alpha in this. Here a1, a2 are constants, essential constants, which you have to determine from some initial given condition. So x becomes a1 cos omega is 2, so 2t plus a2 sin 2t plus alpha by omega square 2 by 4. Omega is 2, omega square is 4. So x becomes a1 cos 2t plus a2 sin 2t plus half. Now a1 a2 are two constants. We have to find a1 a2. Now it is given at time equal to 0, x coordinate is 1. So substitute t equal to 0 and x equal to 1. a1 cos 2 into 0, cos 0 is 1, a1 into 1, a1 plus a2 sin 0 is 0, a2 into 0 also 0, 0 plus 1 by 2. Alright, fine. I love this one. So now a1 becomes what? a1 just becomes 1 minus half, which is nothing but half. Now we have to determine a2. Now it is given that at time 0 the block is at rest. So at t equal to 0, block is at rest, meaning velocity v is 0. That meaning at t equal to 0, dx by dt is also 0. So at time t equal to 0, we get dx by dt 0. So first we get the expression of dx by dt. I differentiate this equation with respect to time. So dx by dt becomes, from the rule of calculus, minus 2a1 sin 2t minus 2a1 sin 2t plus 2a2 cos 2t, and d by dt of half becomes 0. So this is the velocity of the point at arbitrary instant. But at time t equal to 0, dx by dt is given to be 0. So this I put as 0. Minus 2a1 into sin 0 is 0. And cos 0 becomes 1, so 2a2. Now this becomes 0 because 0 is here. So 2a2 is 0. So a2 also becomes 0. Okay. So now I have this one. a2 is 0 and a1 is half. So x becomes what? X becomes simply a1 cos 2t plus half. And a1 is what? a1 is also half. X becomes half cos 2t. a1 is equal to 1 minus 2, 1 minus half. So half cos 2t plus half. This is the x coordinate as a function of time. Okay. So at t equal to pi by 4, t equal to pi by 4, what is x? We have been asked to find the position at t equal to pi by 4. So substitute t equal to pi by 4. 2 pi by 4 plus half. 2 pi by 4 is pi by 2. Cos pi by 2 becomes 0. This entire term goes away. Meaning at x t equal to pi by 4, x is how much? Half meter. One answer we have already obtained. Is it clear? X is equal to half meter. One answer we have obtained, which was asked. Now I write this one, okay? Fine. And then we are asked to find the momentum of the object at t equal to pi by 4. The momentum p is equals to mass times velocity. And v is nothing but dx by dt. Now a1 we have determined to be half and a2 is 0. So dx by dt, v is equal to dx by dt. It becomes what? a1 is equal to half minus 2 into half sine 2t, plus a2 is 0. So 2 into 0 into cos 2 becomes 0. That goes away. Now at t equal to pi by 4, we substitute t equal to pi by 4 in this. Minus sine of 2 pi by 4. Pi 4 becomes 2 pi 4 becomes pi by 2. Sine pi by 2 becomes 1. V becomes minus 1. So momentum becomes mass into velocity. Mass is how much? 5 kg. So 5 into minus 1. Minus 5 kg meter per second is therefore the required answer. Okay. So position of the object at t equal to pi by 4 is half meter. And momentum of the object at t equal to pi by 4 is minus 5 kg meter per second, which is therefore the required answer. So these are the two questions which were asked in previous year JEE Advance paper, physics paper, which are solved. See, first question was very straightforward. You just have to differentiate and substitute Vy Vx there. In second question, this you have to know, so you must remember the solution of this equation. It's very important. Invariably, you come across this in every alternate years in JEE Advance paper, you get such questions. So definitely you must remember the general solution of this equation, which is very important. Okay, so you go through it. If you have any doubt, you write down your doubt in the comment box and clarify it. Okay, I'll close it here. Fine.